We have an object moving with constant velocity. Now you must be careful that you cannot use any of the kinematics equations, because the kinematics equations only work for constant acceleration right now. So for constant velocity, what equation do we use? Now you still remember the formula v equals to s divided by t. So do you get s equals to v times t? So this is the only equation we can use if the velocity is constant. You cannot use any other equations. So if the velocity is constant, it's fixed. So what it also means is, if you have constant velocity, you can take the v times t to get a displacement right now. But if, let's say, your velocity is not constant, it could be either constant acceleration or changing acceleration, doesn't matter. Now, if I have a vt graph, like let's say a straight line, then a straight line like this. So how do I find the total distance traveled? So some people would actually use kinematics for this part, and then use this for this part. But there's another easier way, because even this formula, s equals to vt, comes from a basic idea in a graph. Now, if I have constant velocity, it's like this one. Do you realize v times t actually gives you the area of the graph, area under the graph? So s is always equals to area under the graph. Alright, so under the vt graph. So if it is constant velocity, then it's faster to solve it this way lah, s equals to vt. But if it's not constant velocity and you want to find the distance or displacement from the graph, then you can take area under the graph. So in this case, you can take this whole area. Okay, so I just show you, you can take this whole area. Now there's a trick involved. Sometimes their graph, right, v versus t, it doesn't start from 0 like this. Maybe it starts from 2, and then it increases to 5 meters per second. Alright, so and then they ask you to find the distance traveled. So what would you do? Most people would just take the whole area under the graph here, which is wrong, because you must understand in physics, whenever you say area under the vt graph, for example, that means it's going towards the t-axis, right now. You must go to the value where v is 0. That means you have to extend it yourself until 0 here, and then find the entire area up to here. You see the difference? So never get caught if they didn't start from 0, you must still take the area right up to the value of v0. Because do you see that this area here is not the same as this plus this? So it makes a difference, If you didn't take all the way to 0, then your answer will be smaller. Okay? So remember, constant velocity, you can use this, or in any other cases, whether it's constant velocity or constant acceleration, if they give you a graph, it means that from this equation, which is s equals to area under the vt graph, you can also use the same idea, which is s equals to area under the vt graph. Okay?